Okay, let's continue. So at G, it tells us that not x, not x. And if you recall, I told you, if it's one apostrophe, it's the opposite, okay? But when you put two apostrophes, it returns as it is. Therefore, this is just x, okay? And it's not difficult, guys. It's in the properties. Just memorize the properties, okay? So then we do in H, the intersection of something and nothing. This is not the union, it's the intersection. So let me ask you something. You have no, like, it's an empty set. Can you pick something out of nothing? Can you pick up nothing? No, because you can't feel it. Think about it. Can you hold the air? No. Therefore, the intersection of something and nothing is actually nothing. All right? So then we have the union of something and everything. Union is, remember, you're combining the elements. It's like one and everything. We'll have everything. So with J, we have the opposite of an empty set, which is everything. Right? Universal set. Then with K, remember, we already, like for K, we already solved this part, okay? In G, we know that it's X. And all we're doing, once we solve this part, is they have added this apostrophe, meaning it's not, meaning it returns to not X, because remember, it was not X, then it became back to X when you put the second apostrophe. And the moment you put the third apostrophe, it returns to being not X. All right, so then we have the next one, which is L. And so we have notice there's an apostrophe on the outside of the brackets. So the which means it's the opposite. The opposite of an intersection is a union. So therefore, immediately change the sign. The union of, and then let's just scratch this out because we know now it's the opposite. Therefore, the union of X and everything is everything, right? Whoa, what happened here? Okay. Oh, my stars are getting messy. So with M, we have the intersection of not X and X. In other words, it's nothing and something, all right? And therefore, obviously, it will be nothing, okay? An empty set, if you will. So for N, we see that it's X is intersecting the union of X and Y. So X and Y is everything inside, but what are we actually looking for? The intersection, and the only common elements, since X and Y is combined, will be X itself. So with O, you have the union of X and Y and nothing. Y and nothing. Anything that intersects nothing is nothing. Okay, and the union of nothing and something is the something. So with P, you have X union X intersection Y. Again, it's just going to be X because you don't know the elements in Y. For all we know, X could be 1 and Y could be 2. That could just be an empty set. So X in an empty set is X, right? We're doing Q. So the union of X, union Y, and the union of X. Notice there's two unions. Therefore, Y is included. So it's X union Y. For R, it's X union Y, union, and notice, it has this apostrophe and it's not an intersection, it's a union. So this actually means, this actually means everything, okay? So the union of X and Y and everything, obviously, come on guys, it's 100% going to be everything, right? So then we have S, which is the union of X union Y. And notice we were looking for the intersection and then of X and Y. So already we have the union of X union Y, and then we're looking for the intersection of X and Y. So whatever this intersection is going to be our answer. We don't know the elements, but we know that X intersects with Y, and there's an intersection of that. So obviously it's going to be X intersection Y. Or in other words, X, yeah, that's what it is. So with T, you have X union X intersection Y, an intersection with X. So if we have the union here, it's obviously going to come back to X, right? Because as I said, this most likely could be an empty set or not, right? But what are we looking for? We're looking for X, the intersection. So therefore it's X. Okay, thank you guys, and I'll see you in the next video.